I'm Anil Kumar, and in this video I'll discuss how to write quadratic equation from given conditions. I've taken three excellent examples here, and we are going to write three types of quadratic equations from these conditions. Question number 1 is, Anil threw a ball from 1 meter above the ground. The ball reached a maximum height of 46 meters in 3 seconds. Determine the equation that will model the parabola for this situation. Now, whenever you're given the maximum height, a good equation to consider is y equals to a times x minus p whole square plus q, right? Since we know the vertex. Question number 2. Determine the equation of parabola with y-intercept at 0, 16 that has zeros, 3 plus square root 5 and zeros at this and this. Is it okay? 3 minus square root 5. So if you are given the zeros, then the best form is factored form, right? Which is x minus x1, the first factor, times x minus x2, the second factor. The third one here is determine the equation of a parabola with rational roots 2 plus minus square root 22 divided by 3. Now this is a tricky question. Normally what I do here is that I write equation in the form of ax square plus bx plus c, and to get the values of a, b, c, we use the quadratic formula, which is x equals to minus b plus minus square root of b square minus 4ac divided by 2a, right? So if you use this formula, see, that is the root, and a, b, c terms can be linked with it. Now let us see how really to work with these examples. So let's take them one by one. The very first question was, Anil threw a ball from 1 meter. That means we are given the y-intercept. Threw from 1 meter means at t equals to 0, height is 1 meter. So we're trying to find what is the height at different instance of time, right? So we are writing this equation in the form of a times x minus p square plus q. Now here we know if time is 0, in that case height is 1. So that is the y-intercept. Now the second point here is the ball reached a maximum height of 46 in 3 seconds. That means we are also given vertex. So that has been reached at 3 seconds. That means time is 3 and the height is 46 meters. Do you get an idea? Now this should help you to get the equation. So let's substitute these values. So using the vertex, we could write height as equal to a times x minus time, which is, I should write t here, not x, since I have changed my variable to time t, minus 3 whole square plus the maximum height of 46. Does it make sense? Now to find the value of a, I am going to use 0 and 1. So that means height when time was 0 is equal to 1 meter. So I am replacing h of 0 with 1, right? So we get a, time is 1, time is 0, time is 0. So we're writing this as 0 minus question number 1. Anil threw a ball from 1 meter above the ground. The ball reached a maximum height of 46 meters in 3 seconds. Determine the equation that will model the parabola for the situation. So let me sketch the scenario here, and then we'll develop the model to represent the situation. So let us say that the ball has been thrown from 1 meter. This is not to the scale, and it goes like this. What we are given here is that the maximum height is reached after 3 seconds. Let's say this is the height, and the height is 46. And the ball is thrown from 1 meter above the ground. So this is in meters, and that time is in seconds. We need to model this particular situation. Whenever you are given vertex, it is always better to use the vertex form. So we can say height h equals to a. T is my independent variable, so I'll write t here minus let's say the vertex point p whole square plus q. Now p and q are defined by the maximum, so we could write this as height equals to a times at time equals to 3, we get height of 46. So we could write this as t minus 3 whole square plus 46. So at this stage we have utilized the point which is our maximum, which is 346. Now to find the value of a, we can use the information that Anil threw a ball from 1 meter above the ground. That is to say that at t equals to 0, the height was 1 meters. So I'm going to now substitute 0 for time and 1 for height. So I get 1 equals to a times 0 minus 3 whole square plus 46. Bringing 46 to the left side, we get 1 minus 46 equals to a times minus 3 square is 9. And that gives us minus 45 equals to 9a, or a equals to minus 45 divided by 9. So what we get here is that a is equals to minus 5. Now we can write down the model or the equation of a parabola which represents the situation as h equals to minus 5 t minus 3 whole square plus 46. Is that clear? So in example 1, what we have done is we have represented the equation of a parabola in vertex form. Now let us see how we can do it for question 2. Question 2 is, determine the equation of the parabola with y-intercept of 0, 1, 6 that has zeros at 3 plus square root 5 and 3 minus square root 5. Now whenever you are given zeros, we can say x-intercepts, the real x-intercepts. At those points, we could actually use factored form. So we could write an equation of the form of y equals to a times x minus x1 times x minus x2. Now here, first root is given to us at 3 plus square root 5. The second one is given to us at 3 minus square root 5, correct? To find the value of a, we are given initial point with 0, 1, 6. So let's call that point a as 0, 1, 6. That will give us the value of a. So we can substitute and solve. So what I will do here is, now we'll first develop a general equation. So we'll write y equals to a times, let me use square brackets, x minus 3 plus square root 5. Let me write it in brackets. Okay. So that is the first factor. The other factor will be x minus 3 minus square root 5. Correct? So I hope this is clear. Basically substitute x1 and x2 into the equation. Now let's open this bracket. So if you open the bracket, you get what? You get x minus 3 minus square root 5 times x minus 3 plus square root 5. Now think like this. Let's say this is term a for you, right? In that case, we know a plus b times a minus b is equal to what? It is equals to a square minus b square. So think this is a and that is b. So we have a minus b times a plus b. We could write this as a square minus b square, correct? So that's what I'm going to do now. So I'll write this as a square means x minus 3 whole square minus square root 5 whole square, correct? That's what it is. So now we can actually expand this. So if I expand, I get x square minus 2ab, which is minus 6x. 9 square, 3 square is 9, and this we get as minus 5. So we can write this as y equals to a times x square plus x square minus 6x and plus 4. So that becomes the quadratic equation. Now to find the value of a, we can substitute 0 and 16. So if I write 0 for x and 16 for y, I get 16 equals to a times 4. Or from here, I can find what a is. So that implies that a is equals to 16 divided by 4, which is 4, right? So once you get the value of a, you can actually write down your equation, right? So the equation basically becomes y equals to 4 times x square minus 6x plus 4, correct? So that becomes your equation. So our answer here is, for the given situation, y is equals to 4x square minus 24x plus 16. Correct? So that is how you could actually provide an equation to model the given situation. Let's move on and take up the third example, which is to determine the equation of a parabola with rational roots. In question number 3, we are given rational roots as 2 plus minus square root of 22 divided by 3. I will actually use a different method to find equation of parabola. So that will give you 3 different ways of finding equation from the given situation, right? I hope you remember that if the equation is ax square plus bx plus c equals to 0, in that case the value of x is what? It is minus b plus minus square root of b square minus 4ac over, everything over 2a. Perfect. So that is what the equation is. Now let us see what we are given. You can relate this with the equation, right? So what we are given here is basically the roots. We are given x equals to 2 plus minus square root of 22 over 3. So if you compare, what do you get? So this is a strategy which I am going to adopt to really find the equation, which is right there, right? So we're going to find this equation. How? See. So if you compare, you get b is equals to minus 2, right? Since minus b is 2, b should be minus 2. Okay. What is a equals to? We know 2a equals to 3, and that gives you that a equals to 3 by 2, right? Which is 1.5. Okay. How do we get c? Within the square root, we have b square minus 4ac, and that should be equal to 22, right? Since we know what b is and what a is, we can find c. Let us substitute b as minus 2 and a as 1.5 and calculate what c is in this equation. Perfect. So let's rearrange. So what we get here is, this is 4, right? So we get 4 minus 22. We'll take this to the right side. So it is 4.5. 4 times 1.5 is 6, right? 4 times 5 is 20. We get 6 here. 6c. So we'll end up with minus 18 equals to 6c, and that gives you that C is equals to minus 18 over 6, which is minus 3. Correct? So once we know all that, we know now what C is, what A is, what B is. So we found that A is equal to 1.5, B is equals to minus 2, and C is equals to minus 3. Perfect. Combining all this information, what we can say is that y is equals to ax square, which is 1.5. We could write 3 over 2 x square, bx, which is minus 2x, plus c, which is minus 3. Does it make sense? So that becomes the equation in the given situation. Perfect. So that is how we can actually get the quadratic equation from the roots. I'm Anil Kumar, and I hope you enjoyed this journey of learning how we can write quadratic functions to model situations, or if you are given the roots or the solutions, how to get back the original equation. And we used 3 different methods for finding it. We actually got the equations in vertex form, factored form, and this is standard form. So finally, we got it in standard form also, right? Okay. So that is how you could do it. Feel free to write your comments, share my videos, and if you like and subscribe, that'll be great. Thanks for watching, and all the best.